Hello everyone, good evening. Welcome to our online class. So in this class we will see more problems on recurrence relations ma. Okay, so this is the previous year question paper problem ma. See the problem over here. What is the problem? He says here, solve fn is equal to 5 fn minus 1 minus 6 fn minus 2, and the initial conditions he gave here, f naught is equal to 1 and f1 is equal to 4 ma. Okay, so how to solve? See, you will get the problem in terms of an or in terms of sn or in terms of fn, anything. It is not a big issue ma. You have to identify which type of recurrence relation it is. That means first order recurrence relation, second order recurrence relation, third order recurrence relation, like that. So first you have to identify. Okay, so how to solve this problem ma? See here, given fn, and bring these two terms this side ma. 5 fn minus 1 plus 6 fn minus 2 is equal to 0. Correct? Given can be written as given. I took all the terms this side. Okay, now what we have to do? We have to check whether other order is correct or not. n minus 1, n minus 2. If it is n plus 1, n minus 1, right? If it is n plus 2, n plus 1, n, like that. Understandable? So that is the order. Here n is greater than or equal to 2. That is another issue. Now what we have to do? First we have to find characteristic equation. What we have to find ma? Characteristic equation. Characteristic equation, fn can be taken as k square, fn minus 1 can be taken as 5k, and fn minus 2 can be taken as 0. Here it is n is greater than or equal to 2 ma. Here n is greater than or equal to 2. Understand? Now find the roots here. So take the calculator and find the roots. We get the roots. K minus 3 into k minus 2 is equal to 0, k1 is equal to 3, and k2 is equal to 2. So 2 roots I got. Correct? So very simple here. Understand? So these methods already we did in mathematics 2 higher order linear differential equation. Now 2 different roots. So therefore fn power h, characteristic equation ma, fn power h. Here there is no right hand side. So therefore you can take directly general solution. Fn is equal to a into k1 power n plus b into k2 power n, because two roots are different ma. Right? Now what is the value of k1? K1 is equal, therefore fn is equal a into k1 is how much ma? 3 power n, plus b into k2 is how much ma? 2 power n. So mark it as equation number 1. So he gave the initial conditions. Now what are the initial conditions he gave here? F naught is equal to 1 and f1 is equal to 4. Correct? Now given f naught is equal to 1, f1 is equal to 4 ma. Understand? That means in place of n, how much we have to take? In place of n we have to take 0. Correct? Let n is equal to 0. So substitute here. If I substitute here, f naught is equal to a into 3 power 0 plus b into 2 power 0. Correct? So that means f naught is equal to how much ma? 1. Anything power 0 is 1. So a into 1 is a. Anything power 0 is 1. So I got a plus b is equal 1 equation. Understand? Now what we have to do? We have to substitute n is equal to 1. Let n is equal to 1. What I get here? f1 is equal to a into 3 power 1 plus b into 2 power 1. So that means f1 value is how much ma? 4 is equal to 3a plus 2b. This is another equation I got. So mark it as this is 2 and mark it as this is 3. Solve 2 and 3. For values of a and b, solve 2 and 3. Understand? So you can solve using the calculator, or we can solve like this also. So what is 3 ma? 3a plus 2b is equal to 4. Multiply this equation by 3. So what I get here? 3a plus 3b is equal to 3. So minus minus minus, this term get cancelled. Minus b is equal to 1. So b is equal minus 1. If b is equal to minus 1, so what will be the a value if I substitute here? So a is equal to 2. Correct? So substitute here, b is equal to minus 1 will come this side, plus 1, a is equal to 2. So therefore general solution, both a and b will substitute here ma. This is our general solution, right? So therefore general solution Fn is equal to, what is A value? 2 into 3 power n. B is how much ma? Minus 1 into 2 power n. That's it. So to find the values of A and B, he gave the initial conditions F0 is equal to 1 and F1 is equal to 4 ma. Understand? Very simple topic it is. Recurrence relation, definitely you get one question. Sometimes if paper is easy, you will get for directly 14 marks, and sometimes you will get for 7 marks. First identify whether it is first order, second order or third order. First order I already covered in the previous video, go through that video. Now we are doing second order. Even second order also, we have complementary function to 4 different roots, 3 different roots. So this is for different roots. If you get a same roots, another one is there, a plus bn into k power n. If it is complex roots, that formula also is there ma. Just go through that video. Understand this problem? What we have to do? First bring these all terms one side, then let F1, you can write it here. If you want, you can write it here. Let F1 is equal to k square, Fn minus 1 is equal to k, Fn minus 2 is equal to 1 ma, or k power 0 you can say. K power 1, like that also you can substitute. So we get the characteristic equation k square minus 5k plus 6. Find the roots k1 and k2. This is general solution, because there is right hand side part is nothing ma. Understand? This is one problem. Next, another problem. Next, second problem ma. Solve an is equal to 6an minus 1 minus 9an minus 2. So what we have to do? First of all, given, one second, right. So given, what is given ma? Given can be written as, bring these two terms this side, an minus 6an minus 1 plus 9an minus 2 is equal to 0. Understand? So n minus 1, n minus 2. This is order only. That means n is greater than or equal to 2. So directly I am writing characteristic equation ma. An k square 6k plus 9 is equal to 0. K square minus 6k plus 9 is equal to 0. This can be written as k minus 3 whole square is equal to 0 ma. So k is equal to 3 comma 3. K is equal to 3 comma 3. Both roots are same. So general solution an, earlier it is in Fn, now here it is in terms of an ma. So an is equal to, both roots are same, no, a plus bn into k power n. A plus bn into k power n. So an is equal to a plus bn into, what is k value ma? 3 power n. Mark it as equation number 1. This is our general solution. Understand? Now he gave the initial conditions, no. What are the initial conditions? A0 is equal to 1 and A1 is equal to 6. So let or given you can write. So given A0 is equal to 1 and A1 is equal to 6. A0 is equal to 1 and A1 is equal to 6. See how simple here. So what we have to do? N is equal to 0, we have to substitute. Put N is equal to 0 in 1. So what I get here? A0 is equal to A plus B into 0 into 3 power n. So A0 is equal to how much ma? 1. Anything into 0 is 0. So A, so in place of n you have to write 0, no, anything about 0 is 1. So I get simply A is equal to 1. Understand? Next what we have to do? Put n is equal to 1, no, 1 in 1. So what I get here? A1 is equal to A plus B into, in place of n you have to write 1. So B into 1, 3 power 1. So A1 value is how much ma? Already he gave 6. A also we know, no, what is A value? Already A is 1. So 1 plus B into 3 power 1. So 3 1s are, 3 2s are 6. 2 is equal to 1 plus B. 1 will come this side. B is equal to how much ma? 1. So I got the value of A and I got the value of B. So what we have to write? Both A and B we have to write in general solution. Therefore general solution an is equal to 1 plus 1n into 3 power n. That's it. See how simple it is. So first identifying the recurrence relation, which type it is. The given problem is what? Second type recurrence relation. So we get two roots, and earlier we got different roots. Here we got same roots ma. Understand? So very simple problem. Just practice it. We will see another problem. Next, problem number 3 ma. See here. So given an is equal to solve an is equal to 2 into an minus 1 minus an minus 2 for n greater than or equal to 2. Initial conditions are what? A0 is equal to 1 and a1 is equal to 2 ma. Understand? So now how to solve here? See given. So given can be written as, bring this all terms this side, an multiply by 2 minus 2 an minus 1. When it comes this side, it becomes plus 2 an minus 2 is equal to 0. So it is in order only n minus 1, n minus 2 and n is greater than or equal to 2 here, correct? So characteristic equation is what? K square minus 2k plus 2 is equal to 0. Now splitting the middle term is not possible. We have to find the roots. Splitting the middle term is not possible. Use the calculator ma. Our k is equal to minus b plus or minus square root of b square minus 4ac is there, no? Minus b plus or minus square root of b square minus 4ac by 2a. This formula is there. So k is equal to b is minus 2 4 minus 8 by 2. So we will get 2 plus or minus root over minus 4 by 2. 2 plus or minus 4 is what? I square, 4i square. We will get 2i by 2 ma. Take out 2 common. I got 1 plus or minus 1i. What I got? I got 1 plus or minus 1i. This is 8 ma. 4ac, no? 8. Okay. So I got k value is what? 1 plus or minus 1i. This is in the form of p plus or minus iq. Alpha plus or minus I beta we used to take earlier. Correct? So therefore, here r is equal to square root of p square plus q square, and theta is equal to, what is theta value? 1 second. Theta is equal to tan inverse of q by p. Theta is what? Theta is equal to how much ma? Tan inverse of q by p. Why we need r and theta? I will tell you. R is equal to square root of p is 1. So p is equal to 1, q is equal to 1. So p square, 1 square is 1, 1 square is 1, r is root 2 ma. Theta is equal to tan inverse of 1 by 1. Tan inverse 1 is how much ma? Tan pi by 4. Tan inverse tan get cancel. Theta is what? Pi by 4. Why we calculated r and theta here? Because general solution an is equal to r power n into a into cos n theta plus b into sin n theta ma. This is the general solution. When the complex roots, there we used to take what is that? E power alpha x into c1 cos beta x plus c2 sin beta x we used to take there, correct? But here r power n a cos n theta plus b sin n theta ma. Now an is equal to r value is how much? Root 2 whole power n. A we don't know. Cos n theta is how much ma? Pi by 4 plus b sin n theta is how much ma? Pi by 4. Mark it as equation number 1. This is our general solution. Now he gave initial conditions. No. What are the initial conditions he gave here? Given a naught is equal to 1, a1 is equal to 2. A naught is equal to 1 and a1 is equal to 2. What we have to do? We have to substitute n is equal to 0 in equation 1, and we have to substitute n is coming. 1 second, let me take it. Right. 1 second. So if I take n is equal to 0, what happened ma? Put n is equal to 0. If I substitute n is equal to 0, I get here a naught, anything power 0 is 1, a cos 0 is 1 plus b into sin 0 is 0. That means a naught is 1. So I got a is equal to 1. So similarly, if I substitute n is equal to 1, I get a1. a1 is how much ma? 2 is equal to root 2 power 1. A into n is equal to 1, no? Cos pi by 4 plus b is equal to 1. So b into n is equal to 1 sin pi by 4. So therefore this is equal to 2 into root 2. 2 is equal to root 2. A is 1. So cos pi by 4 is how much ma? 1 by root 2 plus b sin pi by 4 is also 1 by root 2. So root 2 is the LCM. So root 2 get cancelled here. So what I get here? B plus 1. So 1 will come this side. So b is equal to 1. I got a is equal to 1 and b is equal to 1. So therefore our general solution from 1, what I get here, an is equal to root 2 power n, a is 1 cos n pi by 4 plus b is also 1 sin n pi by 4. Understand? So like that you have to solve these recurrence relations, ma. So understand, first problem which one we did, when roots are different. Second problem, when roots are same. Then third problem, when roots are complex. Okay, these are the three models, general sums in recurrence relation, ma. Understand? So we go for next third order recurrence relation we see in your previous year question papers. Understand? You want one more time explanation? See here, what we have to do, first we brought this all terms one side, correct? Then this is in the order n minus 1, n minus 2. So in place of an you take k square, then 2k plus 2, complementary characteristic equation, right? Then roots are not possible. I took the formula, ma. So square root of k is equal to minus b plus or minus square root of b square minus 4ac by 2a, or if you have a calculator, use the calculator. I got 1 plus or minus 1i. This is in the form of p plus or minus iq. P is equal to 1, q is equal to 1. So I have r is equal to square root of p square plus q square. R is equal to polar square root of 1 plus 1 root 2 theta tan inverse of q by p. This is q, ma. Q by p. So q is 1, p is 1. Tan inverse of 1 is tan pi by 4. Tan inverse tan get cancelled, pi by 4. So therefore an is equal to r power n into a cos n theta plus b sin n theta is our general solution. Substituted r value, then theta value pi by 4, theta value pi by 4. Now initial conditions he gave here, a0 is equal to 1, a1 is equal to 2, n is equal to 0 I substituted, I got a is equal to 1, n is equal to 1 I substituted, I got b is also 1. So both a and b I substituted in general solution. Understand? Okay, this is the second order. Now we'll see third order. So these all problems are called which problems, ma? Linear homogeneous recurrence relations. Okay, so we have next case, that means right side part is what? 0. In the next we have homogeneous non-homogeneous recurrence relations also is there. Those are very little bit tough. So those also is, that means right side. See in the M2 linear differential equation, if right side part is there, no particular integral. So similarly here also, if right side function is there, how to solve that problems also are there, that we'll see in the next video. Now we'll go for third order problem. Now see here, this is third order recurrence relation, ma. Understand? Now see, given how to solve this one, given can be written as an, bring these all terms this side, plus 3an minus 1 plus 3an minus 2 plus an minus 3 is equal to 0. See here, n minus 1, n minus 2, n minus 3. That means n is greater than or equal to 3. Understand? So those three are the three initial conditions. Now what happened here? Characteristic equation an can be taken as, we have to start from 3 k cube 3k square 3k plus 1 is equal to 0. So which formula it is? K plus 1 whole cube, no. So simply this can be written as k plus 1 whole cube is equal to 0. This means k is equal to minus 1 minus 1 minus 1. Three roots are same. Understand, ma? Three roots are same, correct? So therefore our general solution an is equal to a plus bn, three roots here, a plus bn plus c into n square k power n. That means a plus bn plus c into n square into k is how much, ma? Minus 1 power n. K is how much? Minus 1 power n. Understand? This is our general solution. If initial conditions are not given, our problem is over. Only till here you have to solve. If initial conditions are not given, our problem is over, till here you have to solve. But he will give you initial conditions, correct? So without initial conditions, the problem is very small one, ma, right? So he gave initial conditions here. Mark it as this is equation number 1. What are the conditions he gave here? Given a naught is equal to 1, a1 is equal to minus 2, a2 is equal to minus 1. Understand? So substitute this given initial conditions in the general solution, ma. So if I substitute here, what we have to do first, n is equal to 0. Put n is equal to 0 in equation number 1. So what I get here, a naught is equal to, n is equal to 0, 0, then 0 square, then anything power 0 is 1. I get only a. So a naught is equal to 1. That means a is equal to 1. Next, put n is equal to 1 in equation number 1. So n is equal to 1, it becomes a1 ma, a1. So n is equal to a is how much? A is 1 I got. So b, n is 1, b I get, n is 1, c I get, minus 1 power 1 I get. That means a1 is how much ma? Minus 2, 1, minus 1 power 1, 1 plus b plus c into minus 1. Minus minus get cancel, b plus c, this 1 will go this side, is equal to 2 minus 1, 1. So b plus c is equal to 1. I got a 1 equation ma. Understand? Next, what we have to do? We have to substitute n is equal to, what we have to substitute? One second. So what we have to substitute? We have to substitute n is equal to 2. Put n is equal to 2 in equation 1. So what I get here, if I substitute n is equal to 2, a2 is equal to a is how much ma? 1 plus 2b, n is equal to 2 no? 2 square, 4c, n is equal to 2, minus 1 power 2 is what? 1. So a2 is how much ma? Minus 1, 1 plus 2b plus 4c, this 1 will go this side, minus 2 is equal to 2b plus 4c, so take out 2 common and cancel it, minus 1 is equal to b plus 2c. So already we have one equation here, so solve these two, 1 is equal to b plus c, subtract it, minus minus minus, minus 2 is equal to c, c is equal to how much I got? Minus 2. If I substitute c is equal to minus 2, so is equal to 1, b is equal to 3. So therefore I got a value, I got b value, I got c value. Substitute in our general solution. General solution, an is equal, a is how much? 1, b is how much? 3, c is how much ma? Minus 2n square into minus 1 power n. Now whatever the value of n, you can find whole nth term of the equation ma. Understand? So whatever the term, a10, a100, whatever the term you want, you can calculate from this general solution. Understand? So very important and very simple topic it is. So first identify the which order, first order, second order, third order. So if it is third order, you have to solve like this, you get 3 roots. Understand? Okay, we will see another problem in third order if it is there in the papers, otherwise I will solve from the textbook. One second. Okay, next third order recurrence relation, another problem. See here, solve an plus an minus 1 minus 8 an minus 2 minus 12 an minus 3 is equal to 0. These 3 are the initial conditions. How to find is third order? First term, second term, third term and fourth term. n minus 1, n minus 2, n minus 3, 4 terms, correct? So what we have to do? So directly I am writing characteristic equation. You can take, this is k cube and this is k square and this is k minus 12 is equal to 0, correct ma? So use the calculator. So in the calculator, how to use in the calculator? So in the calculator, which one we have to take? Mod, is that visible? Okay, mod we have to take 5, equation in that 4, understand? So 4 we have to take 1 is equal to 1 equal to minus 8 equal to minus 12. So I am getting 3 minus 2 minus 2. So that means first value is k1 is equal to 3 ma. So k2 I am getting minus 2 and another one is also minus 2, repeated roots. That means one is a different root, remaining 2 are same roots. Understand? In the 3 roots, generally we used to get 3 roots no, because it is third order, right? So we got one is general root and remaining 2 are same roots. For this case, what we have to write? General solution an is equal to a into k1 power n for single root, and for these same roots b plus cn into k2 power n. Understand? Otherwise, if you want a plus bn into k1, if you take k1, this is k1 power n plus c into k2 power n, like that also you can take it ma, no problem, your wish. An is equal a into k is how much ma, k1 is how much ma, 3 power n, b plus cn into k2 is how much ma, minus 2 power n. Mark it as equation number 1. Understand? So 3 roots, right? So now initial conditions. What are the initial conditions he gave here? a0 is equal to 1, a1 is equal to 5, a2 is equal to 1. So given a0 is equal to 1, a1 is equal to 5, a2 is equal to 1. Substitute here ma. So put n is equal to 0 in 1. So what I get here? a0 is equal to anything power 0 is 1. So b plus c into 0 minus 2 power 0. So a0 is 1, a plus anything power 0 is 1. I get a plus b is equal to 1. A plus b is equal to 1. I got a one equation. Understand? Next, what do we have to do? So we have to substitute n is equal to 1. If I substitute, put n is equal to 1 in 1, what I get here? a1 is equal to a into 3 power 1 plus b plus c minus 2 power 1. So a1 is how much ma? 5 is equal to 3a minus 2b minus 2c. This is one equation I got. Understand? So next one, what we have to substitute ma? Put n is equal to 2 in 1. If I substitute a2 is coming here. Yeah, it is coming. Okay, let it be down. Right. a2 is equal to n is equal to no, a into 3 square is 9, b plus cn 2n minus 2 square is how much ma? 4. a2 is how much? 1 is equal to 9a 4b plus 8n. So we have to solve 8n ma. This is 1 second plus 8n. So 8n sorry, n is equal to sorry, n is equal to 2 no, 2c ma. Shit. Okay. So 8c it is. Sorry. So now you have to solve 1 and this equation and this equation using calculator. Understand? If you solve these three equations using calculator, what are the values I am getting ma? Let me calculate. Okay. So using calculator, I got a is equal to 1, b is equal to 0, c is equal to minus 1 ma. Okay. If you want to solve these three equations in the calculator. Okay. So now substitute in the general solution. So therefore general solution an is equal to a is 1 no. So 1 into 3 power n, b is 0, c is minus 1 minus n into minus 2 power n. Understand? So this is the third order recurrence relation. Okay ma. So very simple it is, unless if you have a right side any nth term. So that is the different method, non-homogeneous. That we will see in the next video. So if it is equal to 0, most probably he is giving is equal to 0 problems only. If paper is tough, he will give you is equal to some nth term. Those problems also we will see now. Okay. So just go through this video ma. So till here. So then we will see in the next video if right side, if non-homogeneous, if nth term is there, how to solve, that we will see in the next video. Thank you.